Welcome to the InventorCAM Professor video series called Jumpstart, the easy way to learn InventorCAM. I'm Sydney, your InventorCAM professor, and in this session we'll be going through part 2 of our first lesson. We will begin by adding a face milling operation to remove the excess material on top of the part. Right-click on the folder called Operations in the CAM Manager. When we do that, a drop-down opens up with a list of operations we can add to our part. We can then select the first option, Face. If we take a look at this workflow, we'll note that later on also in the program, we have almost all of our operations following the same type of workflow. Starting off with our geometry, going to creating our tool, choosing the levels we want to work on, the type of technology we want to use for that particular operations, and our links of how we want to lead in and lead out of our part. Working in order, the first thing we select is our geometry. To create our geometry in face milling, we click on Define, and we have several ways to choose our geometry around the part. Our geometry is the boundary that actually controls where our toolpath will be created. Now, since I've set our model as a target, I can choose the option Model, and instead of clicking on Define, I can click on this drop down and choose Target. This selection will create a boundary automatically around the outside of the part, and that's exactly where I want my toolpath to work. Once I've done this, I can click on Finish. Next, we'll be selecting our tool by clicking on Select. Since we have yet to create a tool, I will show you how to build one. For this operation, our tool type will be a face mill. The next dialog box we encounter has a few options, but we are only going to focus on 3 of the tabs for right now: the tool topology, default tool and data, and tool coolant. Tool topology allows us control over the physical dimensions of the tool. Now, in these fields, I can give the diameter of the tool, and in this particular case, we'll be using a 100 millimeter face mill. We also can set arbor diameter, corner radius, tool length, outside holder, and cutting length, etc. Next is our default tool data, where we can control our feeds and speeds. Finally, we can control our tool coolant settings. Once satisfied with our settings, we can press Select to accept the tool. Looking at our workflow, we will move on to levels. First up is clearance level, whose value is pulled from our coordinate system settings. Next is our safety distance, which is pulled from our MAC file of our post processor. Then onto our upper level, which in this case will be the top of our stock, and finally a face depth, which represents the surface we want to machine to. That completes the setting of our levels. Moving on to the technology now. In the technology dialog, we have several technologies to choose from, which are chosen from this drop down. We have our hatch, shown here in the picture, giving us a back and forth toolpath, stepping over until our entire surface is machined. Our second option is contour, which drives around our chain and stepping from outside in until it machines our surface as pictured. Lastly, and this is the option we'll be using in our part, is one pass. Because our tool is wider than our part, we can machine the entire face in only one pass, as evidenced by the picture. We also have the option of having a finish pass by adding a value to our offset field and checking the finish box. But we will not add a finish pass here. The last dialog to touch is link. Having selected our one pass option in technology, we only have 2 options on lead in and lead out: none and tangent. Setting it none means the tool will not be leading in or leading out of the cut. By selecting tangent, we can actually lead into and out of the cut by a user-defined distance set in the value field. If we would like to keep our lead out the same as our lead in, we can check the same as lead in box, and it will set the lead out equal to the lead in. Now we can select Save and Calculate in order to calculate our toolpath. This concludes part 2 of our first lesson in Jumpstart. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.